A 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molar of calcium hydroxide. What was the concentration of hydrochloric acid in the original solution? Now, in order to figure out this problem, we need to draw out a picture so we know what it is we need to find in this problem. Based on our picture here and on the balanced equation, in one solution we have 75 milliliters of hydrochloric acid, and since hydrochloric acid is a strong acid, it will completely break apart into separate ions. As we see here, we have 2 ions of hydrogen plus and 2 ions of chloride minus. Based on our balanced equation, we have 2 moles of hydrochloric acid. And we don't know the molarity or the concentration of this solution. And this solution is being titrated with a solution of calcium hydroxide. Now this solution of calcium hydroxide has 27.3 milliliters in it and 0.157 molar in the solution. And since calcium hydroxide is a strong base, it will completely separate into separate ions. We have 1 ion of calcium with a +2 charge and 2 ions of hydroxide with a -1 charge. Now we know that we need to find the concentration of the hydrochloric acid in the original solution. That's what's given the problem. And in order to find the concentration, we need the moles of hydrochloric acid divided by the volume of the hydrochloric acid solution, which was given 75 milliliters, which we will convert to liters later. And we know we can find the moles of hydrochloric acid by finding the moles of calcium hydroxide and then using the balanced chemical equation. To find the moles of calcium hydroxide, it's moles time or volume times the concentration, which we take the 27.3 milliliters and convert that to liters, which gives us 0.0273 liters, times our concentration, which is 0.157, and this gives us 0.00429 moles of calcium hydroxide. Now, in order to find the moles of hydrochloric acid, we need to use the balanced equation written up here. We cannot use the equation M1V1 equals M2V2. This equation will not work because we need to use the balanced equation in order to convert the moles of calcium hydroxide to the moles of hydrochloric acid. Now, in order to use this, we can see from our equation that 1 mole of calcium hydroxide is equal to 2 moles of hydrochloric acid. So we can take the moles of calcium hydroxide and multiply it by 2 to get the moles of hydrochloric acid, which equals 0.00857 moles. So now that we have the moles of hydrochloric acid, we can plug it back into our original equation to find the concentration. So we plug it in, 0.00857 moles divided by 0.75 liters. We take 75 milliliters divided by 1,000 in order to get liters. And once we figure that out, we realize that the concentration of the original solution is 0.114 molar.